Hello students, let us discuss some of the numericals based on enthalpy. This question, the heat of combustion of methane at constant volume is given a value at 298.2 Kelvin. Find the heat change at constant pressure. So what is given and what is to be found out here? You have been given heat of combustion. That means when methane burns in oxygen, certain amount of heat is evolved and that amount of heat is given here. But remember, it is happening at constant volume. Now, from the first law of thermodynamics, we know that heat change at constant volume is nothing but change in internal energy. That means this value which is given to us can be correlated to delta U. Now they have asked you to find out heat change at constant pressure. Now what is heat change at constant pressure? Just in the previous note we have learned heat change at constant pressure is given by delta H. That means you are given delta U, you have to find out delta H. Now to work it out, what you need to do is write the balanced equation for combustion of methane. Combustion, as you know, it is reaction with oxygen. So methane burns in oxygen to give you carbon dioxide and water. And during this process, you can see here, since the temperature is 298.2 Kelvin, which is below 373 Kelvin, therefore the nature of water will be liquid. That is why here temperature is important. Okay. So methane is a gas, oxygen is a gas, carbon dioxide is a gas, and water is a liquid. Now which formula we shall use to find out delta H by knowing delta G? We shall use this formula, delta H equal to delta U plus delta Ng RT, because we know what is delta U, we know what is T, we know the standard value of R, and delta Ng can be found out by using the formula. So when we use this formula, let's find out delta Ng. Now delta Ng is difference between number of gaseous products plus gaseous reactant. So you can see here, in the product the only gas is carbon dioxide, which has a coefficient 1. So we write here 1 minus the number of moles of gaseous reactants. So here methane and oxygen both are gases, so 2 plus 1 makes it 3. So here we have 1 minus 3, which is supposed to be minus 2. There is a small mistake in your note, please make this correction. The minus sign is missing there. Alright, please put this minus sign. So you know what is delta Ng, you know what is T, and you know what is the value of R. So we use the formula delta H equal to delta U plus delta Ng RT. Delta U value is already given, so we put here. Then we correct the value of delta Ng, which is minus. R value is 8.314. T value is 298.2. So putting all together, we find out the value of delta H. Now I request you to solve the numericals from the book. You can try the solved examples and also the exercise questions. Now as per the previous deleted syllabus, heat capacity was not there, but we need to do, as the instruction from board is, we have to do the whole syllabus. So we shall be taking it up later. Now let us learn some of the enthalpies. I request you to take down some of the enthalpy definitions from your textbook. One such enthalpy is enthalpy of reaction. Now as the name suggests, you can understand it is the amount of heat change during a chemical reaction irrespective of the number of moles. So definition you can take down from the book. Now how do we calculate enthalpy of reaction numerically? So you can see enthalpy of reaction is represented by the formula delta H R equal to summation of enthalpy of formation. Delta HF means enthalpy of formation of products minus summation, that means you have to add up, enthalpy of formation of reactants. Now let us take an hypothetical equation. A molecules of A plus B molecules of B giving you a product C molecules of C and D molecules of D. Now how do I find out delta HR for this particular reaction. So here my products are C and D and the reactants are A and B. So as per the formula of delta HR, you have to add up some enthalpy of formation of the products and you have to subtract it from enthalpy of formation of reactants. But we have to take care of the stoichiometric coefficients. So here I assume that coefficient of C is small c, coefficient of D is small d. So they need to be multiplied here together with the enthalpies. So we write C into enthalpy of formation of C plus D into enthalpy of formation of D minus A into enthalpy of formation of A plus B into enthalpy of formation of B. This enthalpy of formation values, standard enthalpy of formation values, you will get at the back of your textbook in one of the appendix. So knowing the values of the substances here, we should be able to find out enthalpy of reaction. Check the definition of standard enthalpy of reaction from your textbook. Remember, there is a slight change in enthalpy of reaction and standard enthalpy of reaction. I leave it on to you to find out the difference. Now here I have given you some equations for which you are supposed to actually just to write the equation for enthalpy of reaction. So I am just giving you the example. Here nitrogen combines with hydrogen to give you ammonia. How do you find out enthalpy of reaction for this? As you can see here, all are gases. That doesn't really matter. Okay. So it will be enthalpy of reaction will be 2 into enthalpy of formation of ammonia minus, since coefficient of nitrogen is 1, we need not write 1, enthalpy of formation of nitrogen plus 3 into enthalpy of formation of hydrogen. That's all you need to write. You need not put the values, but if you are willing to do, you can refer to the values in the textbook at the end of the book, where you will find the standard enthalpy of formation values for all thermodynamic data for most of the compounds. One thing here you have to remember, enthalpy of formation of all elements. Enthalpy of formation of all elements is always 0. Okay. Now when you write enthalpy of formation, few things to be taken care of. You please check the definition of enthalpy of formation from your textbook. Now the points which needs to be remembered are the substance for which you are calculating enthalpy of formation. Whatever equation you consider, 1 mole of the substance has to form in the balanced chemical equation. Second point is, it has to form from its elements only, not from any other combination. The element has to be in their most stable state. Now let us try to understand what we mean by these. You see, if we want to talk about enthalpy of formation of water, you can see one of the ways water can form is by combination of hydrogen and oxygen. Another way water can form is by acid-base reaction. We know acid plus base gives you salt and water. So, can I choose any of the reactions to calculate enthalpy of reaction of water? The answer is no. We cannot choose whichever we want. This reaction cannot be chosen to calculate enthalpy of formation of water because here water did not form from its constituent elements. What are the constituent elements in water? Hydrogen and oxygen. You see, here water has formed from acid and base. So this equation cannot be chosen. Now we may say that we can choose this equation because here water is forming from its constituent elements hydrogen and oxygen. Yes, definitely we can choose this. But you see, one of the conditions is not met here. The very first point, it says that 1 mole of the substance has to form. But here you see in the product you have 2 moles. Now how can you convert it to 1 mole? You can convert it to 1 mole by dividing the whole equation by 2. So when you divide this one by 2, you get 1 hydrogen. When you divide oxygen by 2, it becomes half oxygen. And when you divide water by 2, it becomes 1 water. So that flexibility we have, we can do that. Now let us see, is the third condition met? It says that all the substances should be in their standard state. Now what is the common state of hydrogen? Hydrogen commonly present as a gas, and it is here in the gaseous form. Oxygen is also present as a gas, which is its standard form. So this is the equation which to be used to calculate enthalpy of formation of water. Let us take some more examples. You see, if you want to find out enthalpy of formation of carbon dioxide, here we have one equation: thermal decomposition of calcium carbonate. Calcium carbonate gives you calcium oxide and carbon dioxide upon heating. But can we use this equation to calculate enthalpy of formation of carbon dioxide? The answer is no, because the constituent elements present in carbon dioxide are carbon and oxygen, and it has to be formed from carbon and oxygen only, but it has been formed from calcium carbonate. So this equation is ruled out. Next is carbon plus oxygen. Carbon in the graphite form gives you carbon dioxide. Carbon in the diamond form also gives you carbon dioxide. Now can I choose any of these two? The answer is again no. We cannot choose any of these two. We have to choose this one because the most common form in which carbon exists is the graphite form. Definitely diamond is not the most common form of carbon. So these things to be kept in mind when you find out enthalpy of formation values. Now please remember this very important. Standard enthalpy of formation of any element is 0. Now let us work out this small numerical, which is your problem 6.8 in your textbook. In the textbook it is done in a different way. We shall be using a simpler method. Here they have given you enthalpy of formation of enthalpy of combustion of benzene. So benzene is C6H6. When it burns in oxygen, it gives you carbon dioxide and water, and depending on the temperature you have to find out the state of water. Now enthalpy of formation of values of carbon dioxide and enthalpy of formation of water is given in the question, and what you need to find out is enthalpy of formation of benzene. So we make use of the enthalpy of reaction formula, which is enthalpy of reaction is equal to sum of the enthalpy of formation of products minus sum of the enthalpies of reactions of the reactants. So I already know what is enthalpy of reaction as given in the question. So here coefficient of carbon dioxide is 6, so multiply by 6 with enthalpy of formation of carbon dioxide. Coefficient of water is 3, so we multiply by 3 enthalpy of formation of water, minus enthalpy of formation of benzene, which is to be found out. Its coefficient is 1, so we leave it as 1, plus enthalpy of formation of oxygen multiplied by 15 by 2. But since oxygen is an element, its enthalpy of formation value will be 0. So when we put all the values, we can find out the value of enthalpy of formation of benzene. I think this way if you work it out, it is much simpler. So exactly the same way you can try exercise question 6.14 and some of the other questions 6.12, 6.7 and 6.5. Thank you for the time being.